According to the National Electrical Code 2020, specifically NEC 210.11c3 exception, a washing machine can be connected to a bathroom branch circuit under certain conditions. The NEC 210.11c3 exception states that laundry appliances individually rated at not more than 12 amperes, room air conditioners, kitchen waste disposers, and other motor-operated appliances shall be permitted to be supplied by individual branch circuits. Firstly, the washing machine must be connected to its own dedicated branch circuit with a rating not exceeding 12 amps. This means the circuit is exclusively for the washing machine, ensuring that it does not overload the circuit with other appliances. Secondly, the circuit must be protected by a circuit breaker or fuse rated at 15 amps or less. This protection is crucial to prevent overcurrent situations that could lead to fires or equipment damage. The circuit breaker or fuse acts as a safety mechanism, tripping or blowing when the current exceeds the rated limit. Thirdly, there should be no other appliances or devices connected to this branch circuit except those allowed by NEC 210.11c3. This exclusivity is important to maintain the integrity of the circuit and prevent overloading. Common bathroom appliances like hair dryers or space heaters should not share the circuit. Fourthly, this exception only applies to single-family dwellings. The NEC often has different requirements for residential, commercial, and industrial settings, and this particular exception is specific to single-family homes. There are additional considerations to keep in mind. The washing machine should be properly grounded. Grounding provides a safe path for electrical fault currents, minimizing the risk of electric shock. The electrical box should be accessible and have ample space for the electrical connections. Accessibility is important for maintenance and inspections, while ample space ensures that the wires are not overcrowded, which can lead to overheating. If the washing machine is installed in a bathroom with a bathtub or shower, it should be located outside of the wet zone, at least 3 feet away from any water source. This separation is a critical safety measure to prevent water from coming into contact with the electrical components, which could create a shock hazard. In summary, it is permissible to connect a basic washing machine to the bathroom branch circuit provided that the conditions outlined in NEC 210.11c3 are followed, along with the additional considerations for safety and proper installation. It is always recommended to consult with a qualified electrician to ensure that all electrical work complies with local codes and regulations. They can assess the specific situation and provide expert guidance on the best course of action. The branch circuit is defined as the circuit conductors between the final overcurrent device protecting the circuit and the outlet or outlets. This overcurrent device could be a circuit breaker or a fuse. The purpose of a branch circuit is to supply power to specific loads, such as lighting, appliances, or receptacles. Branch circuits are classified according to their maximum permitted ampere rating or setting of the overcurrent protection device. Common ratings include 15 amp, 20 amp, 30 amp, 40 amp, and 50 amp. The rating of the branch circuit determines the types and number of loads that can be connected to it. For example, a 15 amp branch circuit is typically used for general lighting and receptacle outlets in residential settings, while a 20 amp branch circuit is often used for kitchen and laundry areas where higher power demands are common. The NEC provides detailed requirements for the installation and wiring of branch circuits to ensure safety and proper operation. These requirements cover aspects such as conductor sizing, overcurrent protection, grounding, and the types of outlets and devices that can be connected to the circuit. When designing and installing branch circuits, it is essential to follow the NEC guidelines to prevent electrical hazards and ensure that the electrical system meets the needs of the building occupants. The National Electrical Code is a comprehensive set of standards and guidelines for the safe installation of electrical wiring and equipment. It is developed and updated by the National Fire Protection Association. The NEC is widely adopted in the United States and serves as the basis for electrical codes in many other countries. The purpose of the NEC is to protect people and property from electrical hazards by providing requirements for electrical installations. It covers a wide range of topics, including wiring methods, overcurrent protection, grounding, equipment installation, and special occupancies. The NEC is updated every 3 years to reflect advancements in technology and changes in industry practices. Each edition includes revisions and additions to existing requirements, as well as new requirements to address emerging electrical safety concerns. The NEC is organized into chapters, articles, and sections, each addressing specific aspects of electrical installations. It is essential for electricians, engineers, inspectors, and other electrical professionals to be familiar with the NEC and to follow its requirements when designing, installing, and inspecting electrical systems. Failure to comply with the NEC can result in electrical hazards, property damage, and legal liabilities. The NEC is not a design manual, but rather a set of minimum safety requirements. It is the responsibility of the electrical designer or installer to ensure that the electrical system meets the specific needs of the building or facility, while also complying with the NEC requirements. Many local jurisdictions adopt the NEC as their electrical code, with or without local amendments. It is important to check with the local authority having jurisdiction to determine the specific electrical code requirements in a given area. Overcurrent protection is a critical aspect of electrical safety. It involves the use of devices such as circuit breakers and fuses to protect electrical circuits and equipment from excessive current flow. Overcurrent can occur due to various factors, including short circuits, overloads, and ground faults. Circuit breakers and fuses are designed to interrupt the flow of current when it exceeds a predetermined level, thereby preventing damage to the electrical system and reducing the risk of fire or electric shock. Circuit breakers are electromechanical devices that automatically trip and interrupt the current flow when an overcurrent condition is detected. They can be reset manually or automatically after the fault is cleared. Fuses, on the other hand, are single-use devices that contain a fusible link that melts and breaks the circuit when an overcurrent occurs. Fuses must be replaced after they have blown. The NEC provides detailed requirements for the selection, installation, and protection of overcurrent devices. These requirements cover aspects such as the ampacity of conductors, the interrupting rating of circuit breakers and fuses, and the coordination of overcurrent devices in electrical systems. The ampacity of a conductor is its current carrying capacity, expressed in amperes. It is the maximum amount of current that a conductor can safely carry without exceeding its temperature rating. The ampacity of a conductor depends on various factors, including its size, material, insulation type, and installation conditions. The NEC provides tables and guidelines for determining the ampacity of conductors under different conditions. It is essential to select conductors with adequate ampacity to ensure that they can safely carry the expected load current. The interrupting rating of a circuit breaker or fuse is the maximum fault current that the device can safely interrupt without failing. It is expressed in amperes or kiloamperes. The interrupting rating must be high enough to handle the available fault current at the point of installation. The NEC requires that overcurrent devices have an interrupting rating that is sufficient for the available fault current. Coordination of overcurrent devices involves selecting and arranging circuit breakers and fuses in a manner that ensures that the overcurrent device closest to the fault will trip first, minimizing the extent of the outage. This is achieved by coordinating the time current characteristics of the overcurrent devices. Grounding is another essential aspect of electrical safety. It involves connecting the non-current carrying metal parts of electrical equipment to the earth, providing a low impedance path for fault currents. Grounding helps to prevent electric shock and reduce the risk of fire. The NEC provides detailed requirements for grounding electrical systems. These requirements cover aspects such as grounding electrodes, grounding conductors, and equipment grounding. A grounding electrode is a conductive object that is buried in the earth and used to establish a connection to ground. Common types of grounding electrodes include ground rods, ground plates, and metal water pipes. A grounding conductor is a conductor that connects the non-current carrying metal parts of electrical equipment to the grounding electrode. It provides a path for fault currents to flow back to the source, allowing the overcurrent device to trip and clear the fault. Equipment grounding involves connecting the non-current carrying metal parts of electrical equipment, such as enclosures and raceways, to the grounding system. This helps to ensure that these metal parts are at ground potential, minimizing the risk of electric shock. Electrical boxes are enclosures used to house electrical connections such as splices, terminations, and devices. They provide protection for the connections and prevent them from being exposed to the environment. Electrical boxes are available in various sizes, shapes, and materials. The NEC provides requirements for the installation and use of electrical boxes. These requirements cover aspects such as box fill, box support, and the types of boxes that can be used in different locations. Box fill refers to the maximum number of conductors that can be installed in an electrical box. The NEC provides tables and guidelines for determining the box fill based on the size of the box and the size of the conductors. It is important to comply with the box fill requirements to prevent overcrowding of conductors, which can lead to overheating and electrical hazards. Box support refers to the methods used to secure electrical boxes to the building structure. The NEC requires that electrical boxes be securely supported to prevent them from being dislodged or damaged. Wet zones are areas where water is present, such as bathrooms, kitchens, and outdoor locations. The NEC provides special requirements for electrical installations in wet zones to prevent electric shock and other electrical hazards. These requirements include the use of ground fault circuit interrupters, the use of waterproof or rain-tight enclosures, and the prohibition of certain types of electrical equipment. A ground fault circuit interrupter is a device that detects ground faults and interrupts the current flow to prevent electric shock. It is required in certain locations such as bathrooms, kitchens, and outdoor receptacles. Waterproof or rain-tight enclosures are enclosures that are designed to prevent water from entering and damaging electrical equipment. They are used in wet zones to protect electrical connections and devices from moisture. In summary, the NEC provides a comprehensive set of standards and guidelines for the safe installation of electrical wiring and equipment. Compliance with the NEC is essential to protect people and property from electrical hazards. When working with electricity, it is always recommended to consult with a qualified electrician to ensure that all electrical work is performed safely and in accordance with the NEC and local codes. Always remember to turn off the power at the breaker before working with electrical wiring. Double check with a non-contact voltage tester to make sure that the power is off. Wear safety glasses to protect your eyes, and wear appropriate personal protective equipment. The bathroom must have at least one 20-amp branch circuit to supply the receptacle outlets. These circuits cannot supply any other outlets outside the bathroom. Section 210.11 C3 is specific regarding the bathroom circuits. These rules help to ensure there is enough power in the bathroom and that the circuit will not be overloaded. The NEC provides guidelines for the placement of receptacles in bathrooms. Receptacles must be installed within 3 feet of each basin. A receptacle must be installed in each separate space of a bathroom. This promotes safety and convenience. When considering the washing machine location, ensure that it does not obstruct the required egress paths within the bathroom. Egress paths are the routes people use to exit a building or room in an emergency. Maintaining clear egress paths is crucial for safety. The working space around the washing machine should be adequate for maintenance and repairs. The NEC specifies minimum working space requirements around electrical equipment. Ensure that there is enough room to safely access and work on the washing machine. Consider the lighting in the area where the washing machine is located. Adequate lighting is essential for safety and visibility. If the existing lighting is insufficient, consider adding additional lighting fixtures. Be aware of any local amendments to the NEC that may apply in your area. Local jurisdictions may have additional requirements that supplement the NEC. Check with your local building department to ensure compliance. It is important to use the correct wiring methods for the installation. The NEC specifies acceptable wiring methods for different applications. Use the appropriate type of cable or conduit for the wiring of the washing machine circuit. Ensure that all connections are made properly and are securely tightened. Loose connections can cause overheating and electrical hazards. Use wire connectors that are listed for the size and type of conductors being used. If you are unsure about any aspect of the installation, consult with a qualified electrician. Electrical work can be dangerous, and it is always best to seek professional assistance if you are not comfortable performing the work yourself. Check the voltage of the washing machine and also make sure the voltage of the electrical panel matches the washing machine's voltage, typically 120 volts in a residential setting. If it does not match, this is an obvious red flag and the equipment will not function. It can also be a serious hazard to connect a device to the wrong voltage if it is rated lower than the supplied voltage. Before using the washing machine, make sure all of the safety components are fully functional and in the right state, such as the lid switch and safety interlocks. These are extremely important and will help prevent injury or death. These safety components can save you in the case of an electrical short, or even keep someone from sticking their hands into the machine while it is operating. The washing machine has a motor that operates at a specific speed. If this motor is damaged, this is a serious hazard. An electrician can help repair this issue. If the washing machine has any worn or frayed wires, these need to be replaced by a professional. There are also other codes and standards beyond the NEC, such as local and regional codes, that should be followed. This includes plumbing codes as well, to make sure the water supply to the washing machine is functioning properly.